This is such a nice looking exponential problem. If you want to solve this problem, please pause the video because I'm going to solve this exponential problem right now. Welcome to another video on prime logic. The problem setup looks intimidating, looks daunting, crazy, but I think that's interesting. Once it becomes, once you crack the code, it becomes way easier. So let's bring this term to the other side, kind of, to make it positive. 4 to the power of x plus 6 to the power of x equals 9 to the power of x. Now let's divide each term by 4 to the power of x. So this thing divided by itself becomes 1, simplifies to 1. So 1 plus 6 to the power of x over 4 to the power of x equals 9 to the power of x over 4 to the power of x. So let's simplify that further. So 4 to the power of x over 6 to the power of x over 4 to the power of x, we can simplify that as 3 over 2, the whole thing to the power of x equals, and 9 over 4 itself is 3 over 2 squared, and the whole thing to the power of x. So 3 over 2 squared to the power of x. Because of the relationship of the exponents, we can write it as 3 over 2 to the power of x to the power of 2, right? That's the same thing. So let's substitute this term by another variable. So 3 over 2 to the power of x, let's denote it as, let's name it as t. And we need to make sure that, and pay attention, that this thing here, it's always positive. So no matter what x is, it's always positive. So let's replace it now. So 1 plus, this thing is t now. So 1 plus t equals t squared. So now this original exponential problem has now turned and transformed into a quadratic problem. So in other words, t squared minus t, t squared minus t minus 1 equals 0. So let's now calculate the roots here. So t equals minus b, which is 1, plus minus square root of b squared, which is 1, minus 4, a, and c. So minus 4 plus 4, it becomes 5. This thing, square root is 5 over 2a. So this is square root of 5. Square root of 5 is more than 2, and it's more than 1. So 1 minus something bigger than itself, it's always a negative thing. So we can't accept the negative value because t must be a positive value, right? So we can just take the positive root here. So the final answer of t is 1 plus square root of 5 over 2. That's familiar, right? That's the golden ratio. So now let's substitute it back in. So let me just delete this part. So this is the value of t. And when we know that t equals 3 over 2 to the power of x equals t. So for solving this equation, now let's take the natural log of both sides. So we can say that ln 3 over 2 to the power of x equals ln t. So let's bring x down because of the relationship. So x ln 3 halves, or 3 over 2, equals ln t. In other words, x equals, so now let's substitute the t here. X equals ln t. So what is t? T is 1 plus square root of 5 over 2. 1 plus square root of 5 over 2, or ln, the golden ratio, over ln 3/2. I calculated it and it's around 1.187. And let's put a box around it. So that's the final answer, and that's going to wrap it up for today, guys. I hope you enjoyed this video, and I want you to drop your thoughts and answers, and preferably using different methods and different approaches in the comments below. And don't forget to like and subscribe if you haven't already, and see you on our next video. Prime Logic signing out.